A Yakhchal, which is yak meaning ice and chal meaning pit, is an ancient type of ice house which also made ice. They are primarily found in the Dashti Lut and Dashti deserts, whose climates range from cold to hot desert regions. In present-day Iran, Afghanistan, and Tajikistan, the term Yakhchal is also used to refer to modern refrigerators. The structure typically had a domed shape above ground, a subterranean storage space, shade walls, and ice pools. It was often used to store ice, but sometimes was used to store food as well as produce ice. The subterranean space and thick heat-resistant construction material insulated the storage space year-round. These structures were mainly built and used since ancient times in Persia. Records indicate that these structures were built as far back as 400 BCE, and many that were built hundreds of years ago remain standing, where Persian engineers built yakhchals in the desert to store ice, usually made nearby. The ice created nearby and stored in yakhchals is used throughout the year, especially during hot summer days, for various purposes, including preservation of food, to chill treats, or making traditional Persian desserts like falude and sorbets. Although many have deteriorated over the years due to widespread commercial refrigeration technology, some interest in them has been revived as a source of inspiration in low-energy housing design and sustainable architecture. And some, like a Yakhchal in Kerman, over a mile above sea level, have been well preserved. These still have their cone-shaped, 18-meter-high building, massive insulation, and continuous cooling waters that spiral down its side keep the ice frozen throughout the summer. A Yakhchal's engineering is optimized to take advantage of the physics of evaporative cooling and radiative cooling, and the fact that the arid, desert climate is low in relative and absolute humidity. The low relative humidity increases the efficiency of evaporative cooling due to the vapor pressure differential, and the low absolute humidity increases the efficiency of radiative cooling because the water vapor in the air otherwise inhibits it. In addition, in some desert climates, like those at high altitudes, temperatures drop below freezing at night. Their design is generally split into three areas: the ice house or reservoir, the shade walls, and the ice pits or pools. However, they varied greatly, as some used all three components, whereas others was simply a large shade wall over a thin pool. Most yakhchals operate like a traditional ice house. The tall, conical shape of the building is to optimize the solar chimney effect, creating a convection current to guide any remaining heat upward and outside through openings at the very top of the building. Through this passive process, the air inside the yakhchal remains cooler than the outside. At the same time, the building allows cold air to pour in from entries at the structure's base and descend to the lowest part of the yakhchal, large underground spaces in volume. The yakhchal is built of a unique water-resistant mortar called sarooj. This mortar is composed of sand, clay, egg whites, lime, goat hair, and ash in specific proportions, is resistant to heat transfer, and is thought to be completely water impenetrable. This material acts as effective insulation all year round. The sarooj walls are at least 2 meters thick at the base. They also often have access to a kanat and are sometimes equipped with badgers, wind catchers, or wine towers, built of mud or mud brick in square or round shapes with vents at the top which funnel cool air down through internal, vertically placed wooden slats to the water or structure below. A badgir can also function as a chimney, releasing warm air out the top and pulling cool air in from a base opening or a connected kanat. Air in a kanat is cooled by the underground stream. It is this construction that allows the ice house of a yakhchal to take advantage of evaporative cooling, keeping the structure cool to well below ambient temperatures. The ice inside the structure was often separated using wood and straw to separate the layers of ice and keep them from sticking to each other. Furthermore, most designs incorporated a hole at the bottom that would connect back to the kanat, or simply act as a well for drainage. The temperature differences between shaded and non-shaded area. In most areas where the Yakhchals were constructed often have temperature differences of nearly 15 to 20 degrees Celsius, making shade walls necessary for production and storage, as well as giving workers extra time to harvest ice. A wall is usually built in an east-west direction near the Yakhchal, sometimes as high as 15 m and often as high as 10 m in order to minimize convection losses as well as to provide shade. Due to their height, the base of the walls were often significantly thicker, and in some design the walls were arched and or buttressed in order to support the load. Water is often channeled from a kanat to a Yakhchal, which is used to fill the provisioning pools or used to power the evaporative cooling throughout the ice house. Incoming water is channeled along the north side of the wall so that radiative cooling in the wall's shadow pre-chills the water before it enters the Yakhchal. Ice is then brought from either the ice pools covered by the walls or from nearby mountains to be stored in the reservoir. Many Yakhchals contained ice pools. These pools were constructed to either provision the Yakhchal with water needed for its evaporative cooling to function, so ice could easily be prepped or transported to storage units within, or for the production of ice. Sometimes these pools were channels that were square in shape of dimensions with a depth of 40 to 50 cm, akin to a reflecting pool. Often, no special material was used to finish the channel surface. The ice pools would use the cold of the desert nights and a radiative cooling to freeze water which would later be transported to storage as ice. Please like and subscribe our channel for more interesting videos.